let's go ahead and write each of these degrees into radians. Partner A, tell partner B, what is the awesome proportion? Jocelyn, what is the awesome proportion? And what did you write goes above it? Radians. And this one? Degrees. So we just figure out what they give us. Class, what do they give us? Degrees or radians? Degrees, so we can write it right there. And radians over 2 pi equals 30 degrees over 360 degrees. Now all we have to do is just solve for radians. Here we're going to reduce our fraction. You could cross multiply at this time, but I like to reduce at this time. I have 30 times 1. Here's your hint. How many times does 30 go into 360? And I did this so that you can see when I simplify a fraction, you're just canceling. I'm left with radians over 2 pi equals 1 over 12. So if I cross multiply here, I have radians times 12. And then I have 1 times 2 pi, which is just 2 pi. Class, how do I solve for radians? We're going to divide by 12 on both sides. Now, I'm going to change my 12 to 6 times 2. So I'm dividing by 12 on both sides. Why did I do that, class? So I can get radians to be pi over 6. .30 degrees is the same thing as pi over 6. Let's draw the picture. Pictures are very helpful for students. Let's draw a coordinate plane. Class, if you do half of a circle, how many degrees is that? 180 degrees, or in radians, that's what? 1 pi. Or you can think of it as 3.14 radians. So if we're only at 30 degrees, it has to be an acute angle, right? Something like this. Yes? And then let's convert this to a decimal. I just want you to see kind of like conceptually what's happening here. So you're still using degree mode. Pi is above the caret. Caret pi. I don't think I would like to eat. But there's pi. So I'm going to just type in pi over 6. So pi, or essentially 3.14 divided by 6. And I get that number, 0.52 radians. What I'm trying to show you is that this is not a full or half circle. It's just a little bit of the circle. And this is just a little bit of the radians. So this is 30 degrees, or 0.52 radians, or pi over 6. Okay? So that's just a conceptual of what it looks like. Let's try number 11 together. Partner B, tell partner A the awesome proportion. Ready, set, go. Pablo, the awesome proportion?
Rad over 2 pi equals 1 degree over 260.
Class, what do we have? Degrees or radians? How do you know degrees? Which also implies that if you forget the degree symbol, you will be marked off, because then I'll interpret it as radians. In the last problem, we found 30 to be the greatest common factor. Now, if you don't find the greatest common factor, that's going to be okay, but you'll see that it helps you simplify a lot better, faster. With your partner, I want you guys to try to think about, what do you think is the greatest common factor? What numbers multiply to be 225? You guys think about it. Anybody? 5, okay. You guys think of larger numbers? 25, okay. Ooh, someone said 45. Someone said 9. Let's try 45. 45 times what? And 45 times? So I can cancel here. And you'll actually see your unit conversion. You'll actually see that both of your degree symbols cancel. So you should never see radians equals something degrees. That would be incorrect. So now I have radians over 2 pi equals 5 over 8. And then now you can just apply a math trick called cross multiply. Class in pink, what do I get? Radians times 8. And the other one? Now at this time I'm not going to say 10 pi. And the reason why I'm not doing that is because I want to kind of keep them as factors. This kind of helps you with your canceling. Does that make sense? Class 8 is actually what? 2 times 4. So I'm going to cancel my 8s, cancel my 2. So radians is actually, if you're realizing, it's just a lot of reducing of fractions. 5 pi over 4. Do you see how pi is in the numerator? We treat pi kind of like a variable, so it's going to go second. We don't say x5. We say 5x. So we say 5 pi over 4. And this is our answer. Notice there's no degree symbol there. And there's 2 examples of going from degrees to radians.